So in this video, we're going to talk about two-dimensional analysis. Remember that two-dimensional analysis involves both a value in the numerator and a different dimension in the denominator. For example, a two-dimensional analysis problem would look like converting 40 miles per hour into meters per second. This would be two dimensions. The reason for that is you're going from miles in your distance dimension into meters, and hours in your time dimension into seconds. So this involves two dimensions. We have a distance dimension and we have a time dimension. So setting up this problem, always begin with what you know. We know that we have 40 miles in an hour. Typically, when I do these problems, I like to start with the value that's in the numerator, but you could start with both. The key here is to not do both dimensions at the same time. Just compartmentalize this, chunk it up. Do the distance dimension first, and then go back and convert your time into seconds. So starting with miles and going into meters. This is a conversion you must know. We can go directly into miles. Into meters from miles. So we know that in 1 mile, there are 1,609 meters. So that is a conversion you'll want to remember. You could have also gone from kilometers into meters. There's 1.6 kilometers per mile, and then you would have multiplied by 1,000 to get to meters, but obviously we just skipped that step altogether. So let's check the units and make sure that they are satisfied. We are left with meters in the numerator, which is what we should have according to our question, so that is good. Now, we need to look at our hours and go into seconds. If hours is in the denominator here, we need to move it to the numerator in the next position so that we can cancel the hour unit and begin our descent into seconds. So, we know that in 1 hour, we have 60 minutes. And so we can cancel out our hour units, and we're in minutes, but that's not satisfied because we need seconds. So we know that in 1 minute, there are 60 seconds. Now, let's check the units. Minutes is in the denominator and in the numerator here, so we can cancel those out. Now, for this part, what you are going to do is you are going to break this down, and you're obviously not going to multiply by 1 in the numerator, so it's going to look something like 40 times 1,609 divided by 60 times 60. So 40 times 1,609 is 64,360, and our unit once again is meters because everything else canceled out. So that's meters divided by 60 times 60, which is 3,600 seconds. And once again, seconds is the only unit available to us because everything in the denominator canceled out. So you take 64,360 and you divide it by 3,600, and you get 17.9, ran out of room, meters per second. So that should have been our final answer for that two-dimensional analysis problem of converting miles per hour into meters per second. Let's look at another one. In this question, let's convert milliliters per minute into gallons per day. So let's start with, let's do 15 milliliters per minute into gallons per day. So how we do this conversion is we are going to begin with what we know, that we have 15 milliliters per minute. Now, focusing on one dimension, let's do the volume dimension first, converting milliliters into gallons. Then we'll worry about our time dimension of minutes into days. So, once again, we could do this extra step so that we reduce our error and that is converting milliliters into liters and then going from liters into gallons. That's the most simplistic way to do this. Like I said earlier, you would have a greater chance at making a mistake if you went directly from milliliters into gallons. So I want to try to reduce that as best as we can. So we know that there are 1,000 milliliters in 1 liter, and then we know that in 1 liter there's 3.79 gallons. So, looking at our units, milliliters was in the numerator and in the denominator, we can cancel it. Liters was in the numerator and in the denominator, we can cancel it. So we are left with gallons, which is exactly what we wanted. Now, working on our minutes and days. We know that there are 60 minutes. I'm going to try to cram this in so we don't have to separate out the bridge. There's 60 minutes in 1 hour, and then we know that there are 24 hours in 1 day. So let's look at these units. Minutes in the numerator, that's gone. Hours in hours, those are gone, and you are left with days, which is in the denominator. And checking on our units up here, we wanted our answer in gallons per day, and we have that. We have gallons per day. So, breaking this apart, once again showing you guys how to do this, is in the numerator, you're going to take 15, multiply it by 3.79, multiply it by 60, multiply it by 24, and divide it all by 1,000, because that 1,000 is the only true value in there. It would be 1,000 times 1 times 1 times 1 for 1 liter, 1 hour, 1 day. So 1,000 times 1 times 1 times 1 is just 1,000. So in our calculators, we are going to do 15 times 3.79 times 60 times 24, and we're going to divide it by 1,000. So your final answer should be 81.9 gallons per day. Now, last one. Perhaps we'll make this one just a little bit more difficult, but I'm concerned about the amount of room I have available to me. So I'll do my best. Let's do, excuse me, let's do 200 miles per hour into kilometers per decade. So, always start with what we know. We know we have 200 miles, and we have covered that distance in an hour. It looks like I put 3 M's here, miles. So converting miles into kilometers is a very easy one-step process. We have miles up top, so miles has to go on the bottom, and we know that in 1 mile, we have 1,000, you're stupid. It's not 1,000, it's 1.6 kilometers, or in 1 mile. I was going to say there's 1,609 meters per mile, so I apologize for that. So, checking our units, miles is gone, and you're left with kilometers in the numerator, which is exactly what you want. Good. But now we need to focus on taking our hour unit and going into decades. It's going to take quite a long time to get there. So, we have 24 hours in 1 day. Then, we know that we have 365 days in 1 year. And then we know that in a decade, there are 10 years in 1 decade. Trying to squeeze that in. Perfect. In 1 decade. So let's check our units. Hours and hours are gone. Days and days are gone. Years and years are gone. And you are left with your unit of decade, and that is what we wanted in the denominator. So how we do this is, since the denominator is all 1 times 1 times 1 times 1, it is going to be all over 1, whatever it is. So it's 200 times 1.6 times 24 times 365 times 10, all divided by 1. And so when we do this, 200 times 1.6 times 24 times 365 times 10, you get, I'm going to need a little space, you get 28,032,000. And this would be our units of kilometers per decade. So typically with a unit or number this large, we would put this in scientific notation. How you do that is you move the decimal between the first two numbers, which should be between 1 and 10. If the number is greater than 10 or less than 1, it cannot be correct scientific notation. So the decimal needs to go between the 2 and the 8 in order to achieve that between 1 and 10. If you put the decimal between or in front of 2, then it would be 0.28, and that's less than 1 and not acceptable. And if you put it after the 8, it would be 28, which is above 10 and unacceptable. So our decimal should fall right in between the 2 and the 8. And then you multiply it times 10 to the power of the decimal. So you move the decimal once, twice, 3 times, 4, 5, 6, 7. So it'd be 2.8 times 10 to the 7th. That would be a more acceptable way of writing that answer. So I hope that this video has helped you gain a little bit more of an understanding of two-dimensional analysis. As mentioned, we will talk a bit further about this in class.